Okay, so this lesson has to do with using similar triangles to help explain slope. In a lot of testing situations, they like to give you slope questions with regards to similar triangles. Now, similar triangles we'll talk about more in depth later, but it's just triangles that are the same shape, but not necessarily the same size, yet their side lengths are proportional. Questions will talk a lot about the ratio of the vertical side length to the horizontal side length, and we've talked about it in terms of rise over run. Now you know that rise, we talk about the distance vertically that the line is changing, and run, we talk about the distance horizontally that the line is changing. So when you see these words, vertical and horizontal, they're really just talking about the rise over the run. So don't let that turn you around too much. Okay, so look down here at this example. It says the graph shows two triangles. Which statement is true concerning the slope of the line below? They're talking about this continuous line right here. Let me highlight that line. They're talking about this line right, this line right, gosh darn it, right here that is contained in both triangles. So if I'm looking at the slope, I'm seeing that on this triangle, I'm going down 2 units and over 4 units. On this smaller triangle, I'm going down 1 unit and over 2 units. So I've got negative 2/4 and does that equal negative 1/2? Well, if I were to reduce the fraction, simplify the fraction, I can do it on my calculator. I can do control divide and put negative 2 on top and 4 on bottom and just hit enter, and lo and behold, it will reduce it to negative 1/2. So actually these two triangles, the third side of the triangle, does have the same slope because it's on the same line. Alright? So it says, which of these statements is true? It says the slope is equivalent to the simplified ratio of the horizontal side length to the vertical. Horizontal is the run, and vertical is the rise. Remember, we've told you when it's comparing two things and it says one to the other, this language right here, to the other, right? That means that you put this one on top, run, so this would be run over rise. Do we talk about slope in terms of run over rise? No, we do not. We do not talk about it in terms of run over rise. All right? It says it's equivalent to 4 over 2. Well, no, we said the rise is negative 2, the run is 4. That is not equivalent. It says the slope is equivalent to the simplified ratio of the vertical side, vertical is the rise, to the horizontal, that is the run. And since they used it vertical to the horizontal, that means the vertical goes on top, the run goes on bottom. Oops. And is that looks like rum. Rise over run. And yes, that is the way we want to see slope. This is the correct answer. And it's not equivalent to 1/2. This is a negative slope. You know, my finger's going down if I follow the line. So this one's not correct either. It should be negative 1/2. Okay? All right. So let's look at example 2. It says use the graph below to determine the slope of all 3 triangles. All right. So I see for triangle ABC, from point to point, this is going up 3 units and over 2. That is 3 over 2. All right, for triangle CDE, which is this triangle here in the middle, CDE is right here. So this from point to point is going up 1, 2, 3, 4, 5, 6 units, and over 1, 2, 3, 4, 6 over 4. I'm going to come back to that in a second. And then the big triangle here, this is 6, 7, 8, 9 over 1, 2, 3, 4, 5, 6. 9 over 6. Okay, and remember we said that the horizontal over the vertical over the horizontal should equal the vertical over the horizontal, which should equal the vertical over the horizontal. It should be the same for all three because they share this same line that is a straight line. There is a constant slope there. So let's see what happens if I do 6 over 4 in my calculator and hit enter. Oh, it equals 3 over 2. Look at that. All right. If I do 9 over 6 and hit enter, oh, it also equals 3 over 2. So the slope is the same for all three similar triangles. 3 over 2. And that is today's lesson. That's it.